Hello everyone, my name is Thomas Kim. Today is June 29th, 2019. This is my 41st episode about the future of C++ programming, C++ 2A standard. This is second episode about the fundamentals of C++ template metaprogramming. This is my previous episode. This episode continues from my previous episode. So if you haven't watched my previous episode, please click this link and watch my previous video. In this episode, we will learn how to control type deduction of template parameters, also template member data, also function called template parameters. If we lose our control of type deduction of template parameter, that's the beginning of our misery as C++ programmer. So having tight control over type deduction is the first step for successful template metaprogramming. To follow this episode, please visit extension.talkplayfun.com website. From this site, click this button to download our complete source code, especially our previous source code. Click this button, show in folder. Please unzip it. In CPP Extension folder, you can find the tutorials folder. In this tutorials folder, I will create a new file for this episode. Please copy this folder, copy and paste it to your working directory. If you are new audience to my YouTube channel, you have to watch this video and install latest version of Microsoft Visual Studio 2019 on your machine. After installing Microsoft Visual Studio, I also recommend you to install GNU G++ and Clang compiler on Windows. By watching this video, please install latest version of GNU G++ and Clang compiler. You also need to install Intel Threading Building Block library. Please watch this video. After installing these tools, please watch this video. If you don't create command prompt and proper system environment variable settings for our development, you may not be able to follow this episode. If you open this folder, CPP Extension folder, in Visual Studio, I will open the folder. You can find Tutorials folder under CPP Extension. Now click this button, 041, tight control.cpp, hit enter. Ctrl V, Ctrl plus. Include talk play fun, output HPP. Talk play fun, access stream, auto, enter. Talk play fun, enter. Before I start this episode, I will make clear about the terms we are going to use, okay? Template, type name, type, void, function, type, arg, okay? In this configuration, type is called template parameter, okay? Here arg is called function call template parameter, or simply called function call parameter. And here void test function call. Function, we are calling this function like this, int. Then we provide int m5. Here we are calling this function, this part, type in the angle bracket is called template argument. Okay, and this m is called function call argument. This looks pretty ugly, so I will give you another example. int double d 5.0 function double d. Again, double d is template argument, d is function call argument. Please note that parameter, this is type is template parameter, arg is called a function call parameter. In this case, this int in angle bracket is called a template argument. Okay, and here m is function call argument. In this case, double reference is called a template argument, d is called a function call argument. So in modern C++, parameter and arguments are used differently. In old C language or C++ language, parameter and arguments are synonymous. In old C and C++, parameter and argument are synonymous. Okay? In older C++, parameter and arguments are synonyms. Now they are used differently in modern C++. Now I will create a function. Now I will create a class template, type name type, class non-reference member. Here private, I use this template parameter type mmember. Public, I copy this class name type member mmember member. This is constructor. Now I copy this class non-reference member with a forward constructor. Please note that this class and this class are exactly the same. These two classes, this class and this class are exactly the same, but this part is different. std forward. Here I use this type. Okay, this class and this class are exactly the same, but for constructor. In this class we use constructor std forward. Now I will add a member here, void report I will use this string class, stream type over type, talk play fun, get type name, type. and stream type of M member. Talk play fun. Get type category M member. And now I will copy this function. Copy and paste. Please note that this type is template parameter. The type of type and the type of M member are always the same. Okay, so this type, the type of this type parameter and the member type are always the same. Okay, also here the type of a type and the type of M member are always the same. The difference is here. From this class, the constructor parameter is the same, but initialization method is different. Now let's test how they are different. Void test non-reference member classes. We are first using this class like this. Int M1. We can provide, for example, 10. Okay? This works. This works successfully. Now I introduce another one. Non-reference member. This is I-value reference. M2 10. This does not work. Okay, this does not work. We are calling this function. Now let's try if it doesn't work. int main. I call this function. Now I start command prompt. We are in CPP Extension tutorial folder. The file name is 041 tight control. CL EHSC SDD C++ 17 041 tight control .cpp fe aexe, hit enter. CLS, once again, it does not work. Okay? Let me explain why it does not work. So let's see each constructor, non-reference member. This is the constructor. I will copy it for your reference. I copied and I will paste it here. Now let's see this. Here we set the type parameter as int value reference, like this. int value reference member 10. Okay, please compare with this. This type is value reference. This type is value reference. This member is here and this 10 is here. Up to this point it's okay. The problem is here. Okay, now let's think about this M member. If we go up, M member and the type of type and the type of M member are always the same. So int M member, and we are initializing here like this, M member. This does not work. This does not work because at this point member is value reference. I say the type of member here is value reference. But its value category is value. You are assigning value to value reference. This is illegal in C++. If you want to fix this problem, then you have to do like this. int value reference M member std forward int member or you can do this. M member std forward decl type member Okay, this is also works. Or int M member std move member. This does not work. But all these three, 1, 2, 3 works. In our case, we have not used std forward. For such case, in this class, non-reference member with forward constructor, we used std forward like this. So if we try this, now I will disable this too, and I will disable it too. I said it does not work. Now we try with this constructor copy and pasted M3 integer I value reference M3 10. It works because the constructor we used std port. If we compile it, it should successfully work. Okay, it works successfully. Now here we will use report function. M1 report, M3 report. Okay, now we build once again. CLS. In this case, int member is int, and in this case, type is integer I value reference. Member type is also integer I value reference. I forgot one thing here. Okay, I will restore it. In this case, this works. This also works. int I value reference m member std forward integer I value reference member. It also works. Okay, if we build it, it also works because of reference collapsing rule. Of course, it works. For more about reference collapsing rule, please search for std forward. Then you can find all about std forward non-deduced context 2 over n, and all about std forward we need to move forward 1 over n. In these two videos, I explained what is reference collapsing rule and also explained about std forward. Now going back, in this case, this class, this is member. Type and member are always the same. Also in this case, the type of type and the type of member are always the same. The difference is in constructor. We used std forward type like this. Here, this is actually the same. Okay, this is the same like this. You can do the same like this. DECL type member. You can also do this. Okay, so I will give you in summary. I will create another function for the comparison of two classes. I will declare int m equals 5 non-reference member int m1 m1 report non-reference member integer reference m2 m non-reference member int I value reference m3 5. It does not work. Okay, as I explained. Now here we are comparing with this constructor int m4 m. It works. M4 report I will copy it once again. Integer L value reference M5 MWalk. I will copy it once again. Now this is R value reference. It is 6, 5 or 6. It doesn't matter. M6 report. Now I will copy this function name. Copy. Paste. We build. CLS. I will give here a carriage return. And for easier comparison, I build once again CLS. I forgot here report. M2 report. I build once again CLS. So in this class, non-reference member class, type of int, type of L value reference is allowed. In this class, in this case, type int, type L value reference, int L value reference, int I value reference, all types are allowed. In this case, the type of type and the type of M member are always the same. The allowed type for type and M member are int non-reference type, L value reference type. Of course, constant int, constant L value reference are allowed. Of course, constant int, constant double, etc. are allowed. But int I value reference is not allowed. Now in this class, again, the type of type and the type of M member are always the same. All possible types in C++ are allowed for type and M member type. Now let's think about this template, type name type, class, L value, reference, member. Template, type name type, class, I value, reference, member. Private, type, M member, private, type, M member. At this point, if the type of type is int, that is type is int reference M member, so the type of type is int. The type of M member is integer L value reference. Watch this line carefully. At first glance, the type of type and the type of M member might seem always different, but that is not true. The type of type can be int, L-value reference. The type of member can also be integer reference. That is, the type of type and the type of member can be the same. One thing we can say for sure is that both the type of type and the type of member can never be R-value reference type. Now let's move on. Here, the type of type can be int, integer L-value reference, integer R-value reference. The type of member can be integer reference and integer R-value reference, but can never be int. I will explain more about R-value reference member class and L-value reference member class in my next episode. Please visit C++ library extension talkplayfun.com website. By the time you watch this video, if you click this link, you can find tight control CPP this source file in the tutorials folder. Please don't fail to watch my next video. Please subscribe to my YouTube channel. Thank you for watching.